When you picture a brand new pipeline, you probably imagine this perfectly clean, empty steel tube just waiting to go into service. But, well, the reality is a whole lot messier. So today, let's pull back the curtain on the incredible unseen world of getting a massive pipeline from a construction site to a fully operational, safe-to-use asset. Before even a single drop of oil or gas can flow through it, we have to ask a really important question. What is actually hiding inside that brand new, miles-long tube? And as you're about to see, it's a pretty surprising and, frankly, kind of gross mix of things. Yeah, we're not just talking about a little bit of dust here. We're talking about leftover work gloves, plastic sheeting, sharp little bits of metal from welding, sand, rust, and yeah, even animals and insects that decided to make it their home. If you leave all that junk in there, it can clog up valves, wreck expensive equipment, or, worst case scenario, lead to a total failure. So, how do you deal with this mess? Well, in this explainer, we're going to walk you through the whole playbook. We'll start with the risks, then we'll move on to a massive flooding operation. We'll meet the robotic cleaning crew, witness the final high-stakes test, and then tie it all together to see why this process is so critical. Okay, first up, an unseen, risky world. This is all about understanding the core problem here, that a shiny new pipeline is actually an untested, unproven, and potentially dangerous piece of equipment right off the assembly line. The solution is this super-engineered three-part process. It's called flooding, cleaning, and gauging, or FCG for short. Seriously, think of it as the ultimate quality control checklist before a pipeline is ever allowed to go live. Each step perfectly sets up the next one to make sure that pipe is totally clear, spotlessly clean, and structurally sound. And that brings us to the first part of our solution, the Great Flood. You see, before you can clean the pipe or test it, you have to fill it. And that means pumping in millions of gallons of water and, crucially, getting all of the air out. Now, there are basically two ways to get this done. If you get lucky and the train is on your side, you can use gravity to just let water flow downhill and fill the line. It's a much gentler way to do it. But for most pipelines, the long, flat, or uphill ones, you need some serious muscle. We're talking high-capacity pumps that force the water through the entire system. Either way, the main goal is exactly the same: push every single pocket of air out of that pipe. The level of precision here is absolutely critical. Engineers are aiming for what you could call a Goldilocks speed. The water has to move just fast enough to push all the air out in front of it, but it also has to be slow enough to prevent these dangerous pressure spikes, they're called surges, that could actually damage the brand new pipe. It's a really delicate balancing act. So, the pipe is completely full of water. Now what? Well, now the pigs arrive. This is where we meet the specialized robotic tools that are going to do all the heavy-duty cleaning from the inside. And no, we're not talking about the farm animal. In the pipeline world, pigs are these highly engineered devices that get pushed through the pipe by the water pressure behind them. Their one and only job is to scrub, scrape, and shove out all of that nasty construction debris. They're basically the pipeline's internal janitors. And it's not just one and done, it's a whole sequence of them. First, a softer foam pig goes through to get all the loose stuff out of the way. Then comes the real heavy hitter, a brush pick, which has these super tough wire bristles that just scour the inside walls, getting rid of any rust or scale. And finally, to be extra sure, a magnetic pig is sent through to snatch up any leftover metallic bits. Okay, let's recap. The pipeline is flooded, it's been scrubbed completely clean, so we must be done, right? Nope. Now it's time for the fourth and final test, making absolutely sure the pipeline is perfectly round and has zero obstructions. This is the moment of truth. The tool for this all-important test is deceptively simple. It's called a gauging plate. It's this perfectly circular, precision-made metal disc that gets attached to another pig. The whole idea is that it acts as an exact template for what the inside of that pipe should look like. Now here's the brilliant part. It's all about the size. The plate is made to be just a tiny bit smaller, between 95 and 97% of the pipeline's actual internal diameter. What that means is if there's any significant dent or a buckle or some other obstruction in that pipe, this plate physically cannot get past it without being damaged. So when that gauging pig finally pops out the other end, the condition of that simple metal plate tells the entire story. If it comes out looking perfect, completely undamaged, that's a pass. The pipeline is clear. But if that plate is bent, or has deep gouges in it, or is even partially crushed, well, that's a clear red flag. It tells the engineers there's a serious problem somewhere in that line that they have to find and fix. There's just no arguing with it. Which brings us to our final section, from debris to delivery. Okay, so after a successful FCG operation, what have we really accomplished? Let's talk about the payoff for all this hard work. What this whole process does is find those tiny, hidden defects that could turn into catastrophic failures years down the road. It ensures the pipeline is not just clean, but safe and structurally sound before it ever sees a drop of product. It also gives the green light for future, more advanced inspection tools to run through, which guarantees the pipeline's health and performance for decades to come. And you've got to know, this isn't some makeshift operation they're running. The entire process, from the first gallon of water to that final gauging plate, is governed by incredibly strict international safety and engineering standards. In a world with stakes this high, absolutely nothing is left to chance. So the next time you're driving and you see a pipeline cutting across the landscape, maybe you'll think about it a little differently. You'll know the incredible unseen journey it took, from a tube full of junk and debris to a clean, verified, and safe piece of infrastructure ready to do its job.